Good morning, guys. 4.6 notes coming here. Some stuff we touched on briefly earlier in the week, just picking up where we talked about this earlier. So if two events are independent, all right, multiplication rule for the probability of A and B is just the probability of A times the probability of B. All right, and then, if they're dependent, not really part of this thing here, but if they're dependent, then the probability of A and B is the probability of A times the probability of B given A. If they're dependent, that's something that we talked about a little earlier this week as well. All right. Other note thing here, the probability of at least one event A is 1 minus the probability of none. So the probability of at least one thing happening is 1 minus the probability of none. All right, go ahead and pause the video if you need to get that down. Rewind it if you need to. I'm going to scroll down and go through some of these questions with y'all, and then you can try the problems in the back on your own. All right, so traffic jam calculator for next week. So here's a probability of traffic jams on Monday through Friday. So looking at these, probability of no traffic jam, remember these are the complements of that. I'm not writing. Probability of no traffic jam is a complement, right? And complements have to add to 1, all right? So probability of no traffic jam would be 0.6, 0.8, 0.7, 0.5, and 0.3. All right. I'm going to skip 1 and 2 because you just get those right off the chart. So Thursday, Friday traffic jam, Friday traffic jam, are they independent? Well, yeah, they are, because nothing that happens in traffic on Thursday really affects traffic Friday. So they're independent, and so we can use our independent rule. So if we wanted to find the probability of a Thursday traffic jam and a Friday traffic jam, all right, so probability of Thursday is 0.5, and then Friday is 0.7. So you multiply those. All right, probability of a traffic jam every day of the week. So again, since all these events are independent, so we'll do 0.4, 0.2, and 0.3, and 0.5, and 0.7. Clearly, this data is not for San Antonio because it's pretty much 1 every day. All right. So think about it. A traffic jam every day of the week means, Monday and Tuesday and Wednesday and Thursday and Friday. Right? So if it's Monday, Tuesday, Wednesday, Thursday, Friday, we have to multiply the probabilities of Monday, Tuesday, Wednesday, Thursday, and Friday. Okay? That's what that means, plain simple English. All right. If we're looking at probability of no traffic jams all week, pause the video if you need to and slow down. So no traffic jams all week. So that's going to be the probability of no on Monday, times the probability of no on Tuesday, times the probability of no on Wednesday, times the probability of no on Thursday, times the probability of no on Friday. All right, so that would be 0.6 times 0.8 times 0.7 times 0.5 times 0.3 and so the complement of at least one traffic jam, okay? So the complement of at least one traffic jam. So so at least one traffic jam, think about that. That means one or more. All right? So the complement would be not one or more, which equals the probability of none. Okay, so the complement of at least one traffic jam this week is no traffic jams. All right, so again, remember our complement rule. So the probability of A is equal to 1 minus the probability of the complement of A. Okay, so of at least one traffic jam this week, well, that's the complement of no traffic jams. All right, so the complement of no traffic jams is going to be 1 minus 0.6 times 0.8 times 0.7 times 0.5 times 0.3. All right, so that's that. Pretty simple, pretty common sense. You try the problems on the bottom on your own. Here to help you if you need to. And that's all we got. And I wish you guys a very, very happy and restful Thanksgiving break. Hopefully you rest up and don't have to deal with me for 10 days. And wishing you all the best. BTP.